Right, so this event is going to be very similar to the webinar format, and hopefully you're aware of the Zoom etiquette, as which Kia mentioned earlier. If you have a question during the presentation, just add them and I'll answer as we go along. You may want to pay attention to the presentation and not watch Tiger King in the background because we have 2 certificate vouchers to give away. So there'll be 2 pop quizzes during the presentation, one at the end of part 1 and another one at the end after the presentation. So, and some of the stuff won't be on the screen, which I'll just be talking about. So you may want to pay attention to the presentation. The winner of each quiz will win a certification voucher. Right, so let's get started. Let me describe at the outset what we'll cover in this presentation. So this will focus on the details of event-driven architecture in a more platform agnostic manner. We will look at the different topologies and design considerations involved in event-driven architecture. At the end of the presentation, you will hopefully have an understanding of the different topologies and also the trade-offs involved between the different choices available. It will hopefully make you better equipped in designing systems with events. So it is more of a meta discussion. And although I will touch upon the options available on the Celsus platform, like platform events, push topics, generic events, I won't cover low-level details for those. You can find that information on Trailhead, and there are a couple of good videos on YouTube as well if you want to know the details about those specific things. Okay. So that's me. I'm Anup Jadhav. I currently work for an insurance company called Azure Underwriting. I'm head of engineering there. I have over 15 years of experience both in development and architecture. I was a Force.com MVP for 5 years, and now I'm part of the MVP Hall of Fame. That's me. Okay, so I've split this presentation in 2 parts. This is part 1 of the presentation where I'll cover what events are and what event-driven means and the different topologies of this architecture pattern. By the end, you should understand the concepts and the trade-offs involved. And in part 2, I'll cover the Celsus specific options. And between part 1 and part 2, we'll have the first quiz. Okay, so in order to understand event-driven pattern, let's take a look at a typical integration scenario, which is usually achieved with point-to-point integration. Let's take an example of a fictional insurance company that has these 4 modules. Okay, you have a customer management module, which masters the customer information. You have a quotes module that keeps track of all the quotes and policies that are created. Then you have a claims module, which is the third-party system, could be an external system that manages the claims workflow. And finally, you have the notification module dedicated to handle all sorts of notifications, email, SMS, and whatnot, and letters even. It's a nice and clean architecture with one component doing one thing and one thing only, so it has nice separation of concerns. Let's say a customer who has home insurance, they call in and they want to change their address. Now, in any other scenario, I might just update the customer management system and that'd be the end of the story. But in this case, a change of address means the change in the policy because the old policy is possibly void. So you want to send out a new quote to the customer. So this means you want to update the address in the quote and claim system, and also maybe send out notification, which kind of sends confirmation back to the customer management system, and it then sends out the notification. You might also want the quote system to send separate notifications. So you would do these point-to-point integrations between these systems. Now let's pause and think about why this approach is inefficient. Okay, so first thing is there's a lot of tight coupling between these different systems. So if one of these things breaks down, if the quote system breaks down, then maybe you can't update an address, and that's probably not acceptable because you're just trying to update that address information. And if you have these tight dependencies, that's not good architecture. There's also high latency in there, and what I mean by that is let's say the customer updates the address online, and if the customer management system then has to update quotes, which then has to update claims and also then send notification. So that adds a lot of latency. There's a high latency in there. And obviously, like I mentioned, there's a single point of failure. If any one of these things fails, then it kind of doesn't update the address. And you've probably seen this in many other systems where you're just trying to do something simple, but it fails and you don't know why. It's also not scalable. I mean, if you want to add a new component to this, so for example, auditing component, point-to-point integration can get quite complex, and you would end up adding a lot more to the interface if you want to just scale this to add one more module. So not great. Okay. So one architecture style that is better suited in this context is the event-driven architecture. The basic idea is to propagate changes or data between systems or module boundary without creating a tight dependency between them. So you basically send changes asynchronously. You accomplish this by sending and receiving events, which reduces the tight coupling that we talked about earlier. It improves latency because when you update the address, that's it. You've updated the customer management, and then the event management system takes over to update the other systems and do what it needs to do. So it improves latency and makes the architecture more scalable. So it's much easier to add a new module to this architecture than to point. So this specific pattern, in a sense, is the core of event-driven architecture. This brings us nicely to the official definition of event-driven architecture. It's a paradigm, software architecture paradigm, promoting the production, detection, consumption, and reaction to events. And what is an event? An event is any change in state that is meaningful in a business process. Okay. So let's look at a high level what this looks like, what this configuration looks like. So you have event producers, and that could be anything that creates events or wants to notify another system of a change in their state. Like we previously saw, the customer management system wants to update the address and quote and claim system. Then you have the actual event. And we talked about this, the only thing I want to mention here is this event can either be a notification or a message that carries state with it. If it's just a notification, it's just kind of saying, okay, here's an update. That's it. I changed something. And then the consumer can do something. It doesn't have all of the information, but consumer can take action based on that notification. Or it could be a message with data inside of it. Now, there is a special name for this kind of pattern, which it's called event carried state transfer. And it's, I think, based off of REST, representational state transfer. I think they just kind of decided to create similar naming for this. So if your event is an event message with data, then it's called event carried state transfer. And we'll see both of these patterns in action where you're just kind of doing events. I mean, there's also a difference between an event and a command. Sometimes people just say it's a notification and a command, where an event producer kind of just says, here's a notification of something changed. But sometimes it's more of a command where you want another system to do something. And if you want to use a command but end up using a notification, then it's kind of like passive aggressive event, in a sense that you actually want another system to act upon that event, but don't design it as a command. Okay. And then you have at the center of this, the event bus or channel. You can think of it as a pipe where an application or module can send its events. And then finally, you have the event processor, and it's the application or entity that actually subscribes to these events and processes it. You have other names for this as well. Some of the people also talk about this in publish subscribe pattern, but again, publish subscribe is very specific. So I just want to kind of keep it very generic to say there's a producer and then you have a processor. And all of this is asynchronous. So once the event producer creates an event, that's it, its job is done. And then it kind of relies on the event bus to do its job to send the event to the right processor. Okay, sorry. So there are two main topologies. So we have the basics sorted. Let's dive into some of the common topologies when you're designing an event-driven architecture. You have two main types. You have the mediator topology and a broker topology. The mediator topology is commonly used when you need to orchestrate multiple steps within an event through a central mediator. Whereas the broker topology is used when you want to chain events together without the use of a central mediator. Right, I'll talk about this in detail. So let's start by taking a look at the mediator topology setup. So the mediator topology is useful for events that have multiple steps and require some level of orchestration to process that event. So for example, if you look at, again, at our insurance example, if there was a requirement that the quote or policy system must be updated before we can update the claim system, which is a very common requirement. You want to update the quotes and policies before you update claims, or even before you send notification, then you want to orchestrate that. And for that, you need, so all of these steps would require some level of orchestration to determine the order of the steps and which ones can be done serially and which ones in parallel. There are four main architecture components here. You have the event queues at the top, an event mediator, an event channel here, and event processes, okay? So the event flow starts with the client sending an event to an event queue, which is used to transport that event to the mediator. The mediator receives that initial event and orchestrates that event by sending additional asynchronous events to event channels to execute each step of the process. And finally, event processes, which listen to these dedicated event channels, receive the event from the event mediator and execute specific business logic, right? So the pattern does not specify what the event queue component should be. It could be a message queue, or it could just be an endpoint, or it could just be part of the mediator itself. You don't have to have a separate event queue. You can just send the event to the event mediator. There are two types of events here, as you can see. There's the initial event that you send to the mediator, and then there's a processing event. So the initial event is the original event, whereas the processing event are the ones that are generated by the mediator and received by the processing components. It's very important to note here that the mediator doesn't actually perform the business logic necessary to process the initial event. Rather, it knows of the steps required to process the initial event. That's all it knows. It knows how to process that initial event and then create additional events for other things. Most common implementation of a mediator would be like an enterprise service bus. All right, so this is very abstract. So let's look at an example of how this is done. So we go back to our example again. You are updating an address. Let's say that creates a relocation event, and you send that to the event mediator. And the first thing event mediator does is it says, okay, I need to notify the change address event. So it creates a change address event, sends it to the right channel, which is subscribed by the customer processor component. It processes that change address. And then you can see then after that, I think you get some sort of notification that that event has been consumed by the event, by the processor. It moves on to recalculate the quote and adjust claims. Now, I've shown an example here where these two, the arrow for those two are the same, which means it can happen in parallel. It doesn't have to happen in serial. So it will do recalc and adjust claims. And after that, it'll send a notify insured event and send that to a separate event channel. Okay. Any questions so far before we move on to the right?
Nothing in
okay, so no, okay, good. So let's think about some of the trade-offs when we use a mediator topology. So in order to achieve orchestration, you have to implement a sophisticated mediator in the form of an ESB, which may or may not be ideal. You know, you have to manage the ESB, and you end up hiring a bunch of integration architects who then tend to become gatekeepers. This in turn creates a dependency on the mediator. So which basically means, you know, any or all integration requires setup in the mediator, which can add to the overall integration cost. So you trade off some of the agility for the complexity that mediator provides. Now, I've deliberately not called these things as downsides, but just trade-offs, because oftentimes, you know, for big enterprise companies with complex workflows that require orchestration and choreography in their system updates, this pattern is perfectly suitable, right?
Anup, just to interrupt you, we have our first question.
All right.
How does it know that the first event is successful? Since it's
a good question. Yeah, so I think it, at a very high level, it will look for some sort of notification. So if the event channel, consumes the channel address successfully, so it then knows that it will be processed in near real time. So it depends on the ESP, but you can either wait for someone to call back, or you can just assume that if it's submitted to the event channel, then that event is successful and move on to the next one. So there's still an assumption that everything happens in real time before you move on to the next bit. Okay. Right, so just to reiterate before we move on, mediator topology is commonly used when you need to orchestrate multiple steps within an event through a central mediator, whereas the broker topology is used when you want to chain events together without the use of a central mediator. So let's look at that. So this is probably the topology that you've encountered when you've looked at Salesforce platform events, which we will look at in part 2 of the presentation. So you can see that there is no central mediator. Rather, the message flow is distributed across the event processor components, sometimes in a chain-like fashion through a lightweight message broker. This topology is useful when you have a relatively simple event processing flow and you do not want or need central event orchestration. Okay, so there are only two main components here. You have the event channel and then the event processor. Okay, I think that's kind of, it's very simple, and we'll talk more about this in the Celsus side of things, but let's look at the example for broker topology. Let's take the same example here. So because we don't have a central mediator, we could chain the event. So we could say that the address is updated, and that creates a change address event that is then processed either simultaneously, or you could create separate event for that. But in this case, I've said, okay, claims process and quotes process will consume those events at the same time, and then they might create their own events afterwards, which is then processed by the notification processor. So it's there is no mediator here. You can potentially chain the events by creating different types of events that are consumed by different processors. So that way you can create some sort of order, but then again, there are no guarantees because events are managed and consumed asynchronously. So you have to be very careful that the systems are sufficiently decoupled and don't end up overwriting changes. Right, so that's the yeah, I mean, there is no central mediator, which kind of gives you a high agility if you want to add a new component like the audit component I talked about. So it doesn't impact the other components that are in play, and it can just subscribe to any new events emitted by the current processes and log them separately. But obviously, there are trade-offs. There is no mediator, so you cannot orchestrate. If you want orchestration, then you want to look at the other pattern. This probably makes the solution more scalable, but yeah, you just have to you have to trade scalability with orchestration. Since any application can publish an event, which is then processed by another application, and if the events are very granular, we'll talk about the granularity of events. If they're very granular, we'll find that there are lots of events flying around. It will be difficult to keep track of all of these events unless you also have a robust event monitoring system in place. Okay. By the way, Salesforce has something called as event monitoring, and it's part of the Shield platform, but it has nothing to do with monitoring platform events or streaming events. It's just used to track changes at the platform level, which is out of scope for this presentation, and you can check it out afterwards. So event monitoring, even though it has event in the name, has nothing to do with the streaming events in Salesforce or platform events. Right, a few more design considerations. So if the requirement is to have atomic transactions, that is, all systems should be updated or none. So if you take the example of the insurance company, if it says that either we update everything or none of it is updated, if that's the requirement, then event-driven architecture is not a good fit. It is possible, but less likely that the events might expire before another application can consume it. So you cannot guarantee transaction atomicity. Okay. The next question to tackle is, so are you just merely notifying other entities, or are you sending data as part of the event message? So if it's the latter, then you have to decide how much data should that event contain, right? So if you're sending data, then you have to make a decision as an architect whether that event will just be an address event, or do you want to send a person event that has other information in it, including the address. and that'll have an impact on the event granularity. If the events are too granular, if you're just sending an event for name change and then address change, and then another event for mobile number change, then you'll end up with a lot of events in the system. There'll be a lot of events flying around, and possibly will become difficult to reason about a state change of the overall system. So you have to decide what's the right fit. So, and you don't want it to be too generic either. So maybe you don't want one JSON that contains all of the changes and that's the only event in the system. So you want to find the right balance between the event being too granular or the event being too generic. All right. And the next thing to consider is the idempotency of events. This basically means if you process the same event more than once, it will result in the same output. Now, this is a very hard problem in distributed systems. There's no perfect solution, and it's probably, especially in the Celsus world, it's taken care for you by the platform events, event bus, or whatever event bus Celsus uses behind the scenes. So you don't have to worry about it. But if you're not working within the Celsus context, if you're working with an ESP, especially if you're working with a Mediator pattern topology, then you need to be aware that events must be idempotent. For whatever reason, if that event is consumed multiple times, the impact of the output should be the same. Right? And finally, consider the security of your event architecture. This is something that's doesn't get talked a lot in documentation or in online talks. I've not seen anybody mention this, but if you're letting external apps subscribe to these events, you need to ensure that they're authorized correctly to be able to subscribe the events, because you might end up changing the event to include more information that the app needs. And there might be PII data in it, and you're syncing with an external system that probably doesn't have permission to see that kind of data. So you will need to consider locking down access so that external app doesn't subscribe to events that they're not allowed to see. Okay, and so let's wrap up this section.
Sorry, we have one more question. What's the difference between this and hub and spoke architecture?
Good question. So hub and spoke architecture is more like the Mediator topology. So with hub and spoke, you have the hub that kind of manages the spoke. So I think it is similar to Mediator, but not exactly the same, because there's still a lot more. This architecture is more decoupled than hub and spoke would be. I think there's more about, it's more about the dependency and your awareness of these different components. So hub and spoke has high dependency. It's still lower than point-to-point, but it has high dependency than an event-driven. It is sort of an event-driven in my mind. It also has more awareness of what's happening, whereas in a truly decoupled event-driven system, the only way you talk to each other is through these events. That's all you care about. You don't care if there's a claim system or a notification system or whatever. They only focus on sending the right type of events. Okay. Right, I'll assume that answered your question, unless there's a follow-up question. Right, so yeah, let's wrap up this section by going through the pros and cons at a high level. So obviously the pros, you get the high agility with the system. You also, in return, get a high performance because there's low latency, and because these modules are decoupled and events are transmitted asynchronously, the user or the system doesn't have to wait until the whole thing is processed. It's also scalable. Like I said, it's easier to add more modules and components to event-driven architecture. Obviously, the cons, we talked about the lack of atomic transactions. Event-driven architecture does not guarantee this. So if you want to guarantee that all systems are updated and only commit to the whole thing when everything is updated, then you probably don't want to use event-driven architecture. Possibly point-to-point is one solution. It's difficult to reason because there are so many events and so many decoupled components. It can get difficult to reason about the end-to-end flow. That a well-architected system, you have a well-architected system if you can reason about it. I mean, complexity is okay as long as you understand the complication. And if you can't do that, then no matter how fast it is or how simple or complex it is, you cannot reasonably maintain it. I think if it's difficult to reason, it's difficult to maintain, difficult to change. And finally, the event-driven architecture has very low testability. Automation, I mean, you can forget about regression tests, writing automated regression tests for this, unless you kind of write really localized tests, but you can't do end-to-end testing because of the events. It's a bit difficult to test this. Even testing manually can be difficult because you don't know how many events are there, and if you're progressively adding the number of events that are flowing through the system. Okay. Okay, so part two was, so we looked at the part one, we looked at the concept of event-driven architecture, reviewed some of its topologies and related trade-offs. And now let's focus on what Celsus has to offer in terms of enterprise event-driven architecture. So Celsus calls its suite of event-driven architecture components as enterprise messaging platform, because it's all about messaging for Salesforce. It's all enabled by streaming API. So streaming API enables the streaming of events using push technology and provides a mechanism for subscription for receiving events in near real time. So which is basically all the stuff that we saw previously. The streaming APIs are built on the same core technology called Comet-D. And this Comet-D technology is powered by Bio protocol, which is used for, which relies on messaging bus, which offers the publish subscribe mechanism for events, also sometimes called messages. All right, so in terms of messaging platforms, Celsus provides these four capabilities. You have generic events, push topics, platform events, and change data capture. So they're all powered by streaming API, I believe. Generic events and push topics are first generation. This is what was initially released. And I remember using push topics for Visualforce, which is fun. Never used generic events myself, and we'll see why in a bit, because I don't see it being very useful. Platform events and change data capture are second generation, so they were released recently. I would say, by recently I mean a couple of years. I believe it's been out for a couple of years. Platform events, in my opinion, is the supersedes both generic events and push topics, but we'll just kind of do a high-level comparison between all of these. Okay, so let's take a look at what each one of these capabilities look like. Right, so we'll start with push topic. Push topic is it's actually a Celsus object that contains the criteria of events you want to listen to, such as data change for a specific object. So if the address on the account changes, for example, so you define the criteria as a SOCL query in the push topic, and then specify the record operation that you want to execute this query for. So you would say, select address from account and do this for when account is created or updated. In addition to the event criteria, a push topic represents the channel that the client app subscribes to. So push topic is both the message and the channel. So it's kind of it has a dual purpose, and they're tied to Celsus records, and they're auto-published by Salesforce. So you don't have to do anything. Once you define the criteria, Celsus will auto-publish it for you. Okay, moving on to generic events. You use generic events when you want to send custom notification that's not tied to Salesforce data changes. And this is why I don't think it's super useful. I've never used it personally in real production environment. I've read about it, obviously, but because these are kind of general custom notifications, when you want to publish and receive some arbitrary payload in JSON format, it doesn't have an event scheme or anything like that. Okay. Now the next thing, platform events, they're relatively new to the platform, and as I said before, in my opinion, they're the most versatile of all the options. I would argue that platform events should replace G and push topics if they're not already, and you use platform events to publish and subscribe to custom notifications. But the cool thing about platform events is that it has its own custom predefined schema. Now, platform events is the one that actually very closely resembles the broker topology model that we looked at. So just to link it back to the previous discussion, I think platform events, if you want to visualize it and relate to architecture model, it relates to the events broker topology model is closest. It has an event bus that you can publish events to, and other parts of the applications can then subscribe to that. So it has that pub/sub mechanism. It can be used for both notifications and for transferring state. I think you can, it's great for transferring state because platform events are kind of sort of objects in itself and in themselves. So you can add custom fields to it on top of, it's a first class object in that sense. I don't believe you can run reports on it yet, but you can still use it by adding custom fields on it. You can use it for more complex scenarios, right? So that's platform events. You can also define platform events using both code and config, and we'll look at the comparison side by side for all four of these. And finally, you have the change data capture mechanism. You can receive, so the change data capture is very interesting if you want to receive near real-time changes to Salesforce records and then synchronize those changes most likely in an external data store. So if you have an integration requirement where you want to track a record in Salesforce, so most common would be your SAP system wants to kind of track what the changes on your account object or maybe on the opportunity object or something like that. Previously, you would kind of create some sort of API integration or create a connector, but now you can use change data capture, and change data capture synchronizes those changes in real time. It publishes these change events, which represent changes to Celsus records. So changes could include creation of a new record or updates to an existing record, deletion, even undeletion of a record. Okay, and this is also tied to the Salesforce records like push topic is, and it's auto-published by Salesforce. Right, so let's look at these things side by side. And I've used three criteria here to compare these things. So you have the data structure, which for push topic is for a specific S object, and then you kind of define the criteria using SOQL query. Okay, generic events, there is no such data structure. It's just an unstructured string. For platform events, like I said, it's you can define custom type fields, and it makes that solution very powerful. And finally, the change data capture, again, it's defined by the target S object that you're trying to sync. The publication model, it's for push topic, it's auto-published by Salesforce. Same for change data capture, it's kind of auto-published. You don't have to explicitly publish anything. For generic events, you have to write some code using the REST API. And for platform events, it's admin friendly. You can use declarative tools like Process Builder, or you can just use Apex to publish the platform events. And the way to subscribe to these events for both push topic and generic events, you have to use a client that supports the BIO protocol. And for platform events and change data capture, you can use both declarative or coding solution. Okay, any questions before I move on? No, all right. So we have a robust messaging platform to build applications in Salesforce. So how can you exploit these features? So what's the impact? The first impact I would say is before platform events, I'd wager that most of us put almost all of our business logic on record creation or update and triggers. When we're talking about code, by the way, I'm sure I'm kind of excluding the process builder and the workflows for simplicity. But if it was code, or if you wanted kind of a contiguous logic for doing something, you would put everything in triggers in one place. This does mean that everything was in a sense synchronous, and it led to wasted processing cycles because sometimes it would just execute all of the trigger, but you didn't want everything to be executed. But now you have the option to move some of that logic into platform events. This will make your triggers simple and lean, and also improve latency, as now some of these tasks can happen asynchronously. So one of the places that I've seen platform events being used is in custom logging and audit frameworks. So if you want to log something into a custom log table, or if you want to start auditing certain things where you've built your own auditing framework, you no longer have to write that bit inside of a trigger. You can now kind of just create an event to log things, and that improves latency because then it's no longer depends on writing that, committing that change to the database. It's just asynchronous, so it's very useful in that sense. Next is asynchronous equals decoupled. It's building async logic where possible helps improve performance. Hopefully I've convinced you of that, and the agility of the system. It helps you design the modules or components that are decoupled. And there are many benefits of decoupling. They're easier to maintain, easy to extend, and components can change or evolve independently. All right, but what is missing? So it's powerful, but there are still some things that I think are still inadequate yet. So the first thing is the ability to track events. Now you can monitor the events that are still on the bus in some places in Salesforce, but you can't really track events in a more meaningful way. So unless you're kind of focused on one thing where you're testing one business flow, uh, it's very difficult to track these events, and you probably have to write some custom code to be able to log or track these events. I know there's an App Exchange app that provides some sort of tracking. I believe Philippe wrote that app. So if you go to App Exchange, event tracking, event monitoring, or something like that. Again, event monitoring means different things in the Celsus as well. Event monitoring is not the same. But tracking events is still a big challenge, and you can't reason about the system if it's a large system and there are a lot of events flying around. Logging, Celsus logging itself is very much reactive and not proactive. So logging is still inadequate. And again, it goes back to the same thing. They're related in a way, because you can't track, you can't log it properly. And if you want to track, then you have to build logging in some sense. So these things don't come out of the box. You have to be just aware of them. So before you go ahead and start inspired by this talk, and you just kind of start untangling your architecture and start creating events, just be aware that you are creating, an environment where it might be difficult to track the updates to different parts of your application.
Anup,
all right.
Questions?
Yeah, go for it.
So the first one from our certification voucher winner: can you capture and handle failures via Process Builder when creating platform events, or is that only via Apex?
So failures would be, it depends on what he means by failure. So if it's a failure, sorry.
Stuart, and he can ask his question. Stuart, you're on mute.
Yeah, I can't recall, but I think there's a couple of exceptions that can be thrown when trying to submit to the on a platform event. But
so I don't.
It's probably rare, right? But I just wondered.
It is quite rare. I mean, if it fails in committing the event or publishing the event, then you can possibly capture that. But if you're talking about failures afterwards, so if the event's on the event bus and something's gone wrong, or the subscriber couldn't subscribe, or whatever needs to happen didn't happen, then that's probably not catchable in a way. But I don't. Yeah, to be fair, I don't know the details of that, so I'm not 100% sure.
Okay, and the second question was from Richard Clark, basically saying, could you not create a subscriber to the event to serialize to Splunk, for example, when you're talking around tracking?
Yes, you can, but again, it's a custom solution. There is nothing that you can do out of the box. Absolutely, I think it's a solution that I would prefer, an external system that tracks everything. But then, if you're tracking this, you might as well track everything if you're using an external system in Salesforce. So you can even hook up the event monitoring part of Shield into Splunk and get everything in one place.
Okay, so I've just unmuted Rob Cow, who says he's got input on the question asked about capturing and handling failures.
Yep. So whilst it's not Process Builder, we are building something like this currently using Flow, the other declarative tool, and yes, you can absolutely capture failures, but there's different types of failures. So as Anup said, one of the things that we initially capture is whether events are being successfully published. Now we're doing that Apex side initially. The challenge with that is there are two types of platform event. There's standard and high volume. When you publish a standard platform event, with event-bush.publish, it returns a list of database.save results, a bit like the DML operation, and then you can just check the save results in the usual way. If you're using high volume, it doesn't DML it in the same way, so you don't have that database save results returned. It goes, well, we don't know definitively, but the documentation tends to hint at that it's going off platform to a quote industry standard event queue, which means you just have no insult. It's very fire and forget at that point. once you've got past the publishing of the events and seen that it's successfully published, it's kind of up to your subscriber to log a receipt of that. So once it hits your subscriber, you can log whatever you want through Process Builder, Flow, whatever you've got subscribed there.
Cool. Thanks, Rob.
Okay.
That concludes my presentation. And the last thing to say is thank you. Thanks for joining me tonight, spending your time with us and listening to Event-Driven Architecture. Hopefully you found it useful. Let me know your comments or feedback on Twitter or send it to the organizers on how the session went and what else you'd like to hear from us.